My presentation is on using MapReduce to work with large data sets. So first off, bear in mind that MapReduce in this context that I'm showing, it's a single method called MapReduce. So I'm not going to be showing like calling .map on something, then .reduce. It's kind of like if you have a mongoose method where you're doing like capital U user for your user model and you're doing .find, well, we're going to be writing something literally like .MapReduce. So when you see this in articles, it probably means the MapReduce technique. So let's start with a little analogy. Let's say you work for the US Census and you're worker number 1, and you have to go to every household in the United States, and on a sheet of paper you have to record how many occupants are in that house, as well as other things like maybe when they move there and what their names are. Well, you might complain that in order to tally how many people are in the whole United States, that it's too much work to record this on all those pieces of paper and add it all together. So that's why we're going to give you a second worker to help you. As the first worker, you're going to act kind of like the map function. You're just going to return an array that is all the count values. So if you go to 5 households, or 3 households, the first has 3 people, next is 1, next is 2, then the array you return is going to be 3, 1, 2. So your input array is kind of like an array of objects or array of household objects, and you're just returning an array, and you're not going to combine it. You're not going to add all those up. That's the job of worker number 2. He or she is going to take that array of count values and actually reduce it and add them all up. So code time. So I have a little app that I use from a tutorial here. This first file, I'm going to just generate a bunch of dummy data. It's going to be like a user model. It's going to be 100 users. And the goal is to use this node thing here, example1, to find how many males and how many females were in those 100 documents. So I'm just doing it on 100, but this is a technique you would use if you're doing it on like 100,000 or 100 million. If you think back to when you were working in the SQL workshop where we queried the IMDb database, remember you'd wait like a couple seconds, and I think there was something like 40,000 or so actors in that database. So just bear that in mind. This might not be as applicable for what we do with StackStore, but definitely in the future. Okay? So DataGen, MongoJS, this is kind of like an ODM. It basically communicates between Node and Mongo for you. The database I'm creating is called MapReduceDB, and the collection where I'm storing all this dummy data is called source data. Dummy.json, this is the module that generates dummy JSON data. So it comes with things like date of births and names. These are some helper functions that add some additional key value pairs to that dummy data. Here is finally where you insert it. So database, it's collection name .insert. Something funny happened the first time I did this. It was saying completed, but when I went to Mongo Shell, there was no database created. So I saw this error was getting passed in. I decided to log the error, and it said something like maximum size 1,000 exceeded. So what I did was I figured that maybe that JSON data that I'm dumping in, or that I'm adding, called result, which comes from the dummy JSON module, like all those 50,000 documents, might be too large. So I changed it into a JavaScript array, and then I spliced that array to get just 100 documents. Okay? And then finally, I put it back into JSON format as final result. When I passed it in, it went into the database with no errors, and I checked Mongo Shell, and the data was there. So let's verify our data is there and see an example of one. So I'm on my MapReduce database. So it's this one here, source data. So let's see what's in that. So there's an example. So the helper functions populated some of this data for me, like I think it was gender and hobbies or activities, and then dummy JSON came with a lot of other information as well. Okay? So now, the goal here, like I said, is to figure out how many males and how many females are in these 100 documents. So here's example 1 script. So the actual function, like I said when I started, is .MapReduce. So .MapReduce takes 3 things. It takes a mapper function that you're going to perform, a reducer function, and it takes a collection that we're writing these to. So far in all our workshops, we've usually been querying for data and like displaying it on the front end of the screen. Well, sometimes when you're working with a lot of data, you perform things called aggregations. You're just transforming, packaging, preparing your data for future use. So sometimes you're just querying for data and just putting it into yet another collection. So it's going to end up in this collection here, example results. Okay? So once that performs, it's on example results, and then we're going to query example results here, example 1 results, and see the total of how many men versus women are in the database. So the mapper function is run on every document in the source data collection. So it has this unique emit function here that says, oh, if the gender is a male, then on the returning male array, we want a 1. So it's going to add a 1 to that array for each male. So here's an example. When map runs on the source data collection, it's for males, it's going to say, for instance, if there were 3 males, then the male array will be 1, 1, 1. If there was 8 females, it would be 1, 8 times like that. So once those 2 arrays are made, the reducer function is going to take that as an input and return a combined value. So reducer is going to take in a gender, male or female, and that count array, and it's going to return it here. And Mongoose can do this very similarly. It would look a little more like this. It would be user.MapReduce, and then it would still take MapReducer, but it actually just takes it as an object. And basically, you would just define that object ahead of time. And you would still console log your results here. So you would just put the mapper and reducer on here. So we could do o.map equals function. And it can literally use the same thing. So you see the syntax is pretty much the same. The reduce is just a little bit different. Oops. But here it's just going to be return vals.length. Okay? So this is how you could do it with Mongo or with Mongoose. Okay? So let's actually try running this example1.js file now. So here's the project directory, and I'm going to say node example1. I didn't save it, so let's hope it goes. It still gives me an uncut error that came up this morning, but it does give me my counts here, docs_r. So the method was kind of like here I was saying docs_r, and it's logging what we find in that example1 database, or example1 collection, what was populated by this MapReduce function here. Okay? So here's a great example on the MongoDB docs. If you just search MongoDB aggregation or MapReduce, this will come right up. So this is in kind of like the native MongoDB like command. This is something you could run in the Mongo shell itself. So let's say you have a collection called orders. Then the MapReduce can take 3 things. Again, your map function, reduce function, where you want to write it to. And this time, you can actually pass it a query as well. I didn't show it in the previous example, but you can say you want to perform a query on that collection first, and then on that collection, or the queried data, you want to perform map and reduce. So the query is orders with status A. So these 3 here have status A. So this one won't get selected by the query. We get to here. We want to perform map on it. It says we want to get the customer ID and the amount of the order. So there are 2 customer IDs that were A123 with amounts 500 and 250. So it gives us this from our map, customer B212, amount 200. And then finally, reduce will perform on the result of map. So reduce is going to say 500 and 250 for customer A123 is 750, and for B212, it's the same. So here we have our order totals collection table here. And this could maybe be like a scheduled job. Maybe you can have this like running at the end of every business day. So the next day, you have this data already available, and you don't have to go querying it from a much bigger collection, which would be a slower read and write time. So MongoDB has a lot of built-in functionalities for data aggregation and transformation. Sometimes you might find that it still doesn't do what you're looking for, or maybe you need a data warehouse, you're working with so much data. So in that case, you might use something like Hadoop. So this is in the realm of what's called like big data or data warehousing. Hadoop is a product that runs on the Java virtual machine. So I see it as kind of like complementing our mean stack. So it connects to our MongoDB through Node and a Java MongoDB driver. Okay? So some of the things it does, it provides fault tolerance. So it kind of, I see it as like extending MongoDB. It can actually represent our database as a bunch of data nodes. And they can replicate the nodes so that if the read-write job to one node for order data fails, then there's backup copies of that node to get the data from. This makes it more of a distributed system. And let's see how it does parallel processing in the next task. So let's say you're an end user, you're a client, and you want to find all the emails sent to your customer service department that had the word refund in the subject line. Well, if you had 300,000 emails in one database, that might take a while. So one thing you could do is divide that into 3 data nodes, each with 100,000. So then your time complexity would still be the same. It'd still be big O of n, but your n is now a lot smaller. So maybe from this one, they find 30,000, this 0, here 11,000. So that's the map task, and then reduce task finally adds those together and says, oh, 14,000 total. So it's really a Hadoop that is kind of like abstracting your MapReduce tasks away. You can configure them a lot more. You can get into a lot of more nitty-gritty details with it. And bear in mind that we've just been working with like one database in all our studies so far. But sometimes you might be having other databases connecting in. You're not just going to like interface them all together. So that's why you can use something like Hadoop to help connect them together. And when it runs the MapReduce, there's even additional tools out there in data warehousing that can help run the MapReduce jobs. There's one called Pig. Sometimes there's people viewing the data or doing things with the data and making it go elsewhere. So one last thing on how Hadoop works. It has these like data nodes that are for like read-write jobs of the data storage in the Hadoop data file system. And then it also has these job tracker nodes which perform like the map and reduce methods. All right, thank you. Any questions?